every day, everywhere. Certainly, I think most people in the room will be helping us in doing that as well. In terms of our environmental vision, our business is built on sustainability. We as a business operate in a highly regulated area, and one of the things that we do is we try and build the sustainability of that business. So we look to source all of our brands sustainably. We look to deliver them in as sustainable as possible manner. We look to develop our packaging so that we have minimal impact on the environment. We look to make sure that our employees work in a safe and secure and sustainable environment. And in the area that I'm going to talk to you about today, that we produce our products in a sustainable way as possible. So, looking at our environmental vision, back in 2007, Diageo set the business as a whole a set of targets, which I remember at the time being horrified by, because I really thought we were quite good at the time and thought we were performing very well, and yet here we were going to have to improve our water efficiency by 30%, and we use a lot of water. That greenhouse gases were going to have to be reduced by 50% across the globe. Waste to landfill was going to be reduced by 100%, that nothing would go to landfill, and that our effluent loads, again, breweries and distilleries produce an awful lot of effluent, and high nutrient value effluent, and we're going to reduce that by 60%. So you can imagine where we were all sitting there back in 2007 saying, great, fantastic, we're going to have to do this. How are we going to do it? In terms of our targets for this year, in order to hit those targets, we've had to get to a water efficiency of 3.4. We used to be somewhere up around 7.5, so we've completely smashed that one. Greenhouse gases, we've got to come down to 42,000 tonnes. I'll be honest, that's not hitting 50%, because for us, we operate a CHP plant in the middle of our capital. We won't be able to go to biomass, we won't be able to put secondary effluent treatment on our site to generate biogas. So we're struggling with that at the moment, and we're trying to stimulate the green gas market in Ireland so that we can get access to some green gas to decarbonise our energy generation. Waste to landfill, 0, yeah, we've hit that one, and then effluent reduction to 67 tonnes to the environment. To be fair, that's after it has subsequently been treated by DCC, but we have reduced our effluent load to DCC by a very, very substantial amount, in excess of 60% that's quoted there. In terms of our track record in the environment, again, I'll skip through most of this because it's not really what people want me to be talking about. We've tried to lead in this area. We've tried to push ourselves. We were the first brewery to achieve 50,001. We've operated many management systems over the years. Our engineering and R&D work very closely with the SEAI, Enterprise Ireland, and all the other bodies to try and identify, foster and commercialise innovative technologies, and we've had a lot of success in that area. And in terms of previous awards, I'm not even going to go into them, but we have all the certification in terms of 50,001 and also IS 393 and 399 also. In terms of Project Phoenix, what was Project Phoenix? Project Phoenix for us was a huge opportunity. We were going to spend 153 million euros to build brewhouse number 4. We're nearly 300 years in operation on the site in Dublin, and this is the 4th brewhouse. So that's quite an investment, quite a step change for us. It was going to be one of the biggest brewing projects in the world while it was being built. It has actually reduced our cost of goods and created a huge competitive advantage for us. Great news for Ireland Inc. because for us and Ireland Inc. because we're actually repatriating beer which we had lost to foreign markets in the past back into the country. So we're now producing far more export beers, and we're able to do that competitively. We're able to land them in the countries around the globe at a cheaper rate than we could source them locally, which is fantastic news, both for the quality of the product, I believe, but also for us as a business. In terms of energy consumption, it has hugely reduced our energy consumption. I'll go into some of that later on in terms of what the actual outcome of that has been. And we have what we believe to be, now I could be corrected on this, somebody will quote somewhere to me, we believe we have the most energy efficient brewery in the world, brew house in the world. We've certainly invested in all the technologies that should make that so. And we see it as a showcase for the innovative technologies, both within our group, because we are now beginning to deliver similar projects into Africa and into other third-party countries, based on the model that we have fostered in Dublin. So, energy efficient design, 2 or 3 characteristics. I'm by no means an expert in this. Anybody who really wants to get into this, I would refer them to the SEAI website. There's a very, very good set of presentations in there, and the SEAI will certainly help anybody in relation to this. But what are the key aspects of it for me? But what is it? It's a methodology to assist you in maximising the benefit you can derive from a project and installation in terms of energy efficiency and the financial benefits that can give you. Why did we use it? Well, very, very simple. We're a commercial organisation and we want to make money. And what we did was we used it to reduce the energy usage in our operation on an ongoing basis. It actually helped us reduce capital input in our utilities area particularly, but also in the process area. And then in terms of the operational phase afterwards, it enabled us to set up systems that would allow us to manage those operations in a far more sustainable and competitive way going forward, built to allow continuous improvement to be a key deliverable of how we do our business. And also, the simple truth was it can very easily be integrated into a standard project setup. There's nothing miraculous about it. The graph at the bottom, I think, is very, very important. It shows the possible benefits of EED depending on when you introduce it into your project life cycle. And it's absolutely self-evident. You don't need a graph to tell you this, but I think the graph actually speaks louder than words. If you get in at the design phase, and if you challenge all of your design assumptions, and if you challenge every single sacred cow that your process technologist has, that your chemical engineer has, that your utilities engineer has, and say why. Just ask why. Why does it have to be that temperature? Why do we have to have that amount of flow? You'd be amazed the number of times the question will be, or the answer will be, because. And there's no actual substantial reason. Genuinely, you will be amazed. So, in terms of EED, EED is a process like any other. The methodology is very simple. The next part that I want to highlight in terms of it is the project organisation. And I think this is hugely important in terms of getting this right, because this is where we really won out on Project Phoenix. And I think Project Phoenix was sort of one of the forerunners of this becoming a standard, and I think a lot of the learnings from Project Phoenix were built into the standard. Key things are you have to have senior stakeholder buy-in into it. In terms of your team, your business's team, you have to have a strong project team with an identified owner of the EED process. But their raison d'etre is to drive EED, to challenge every assumption, as I said before. And then in the contracting team that are going to deliver for you, they have to be mirrored in terms of the EED expert that they have. Absolutely key that both teams have that in it. Absolutely key you have the stakeholder involvement. The reason you need to mirror it is because you have to have the same passion in both teams. They have to challenge each other. They have to drive each other. And we were very lucky with the 2 individuals we got in place for that. They actually really drove the operation, ably assisted by a colleague of mine, Conor Brown, who I know is known to many people in the room. This is one of these things that builds. In terms of the phases, so what's the first phase? First phase is very simple. When you go to your design phase, somebody will come into you with the standard design. You'll give them a brief of what you want. They'll come in with the standard design, and what we do on everything now is we do a baseline consumption report. We do baselining exercise on it. We look at every aspect of it, we model it, and we figure out exactly what are the inputs, what are the outputs, where's the waste, where's the opportunities. From that, second phase is we generate a register of opportunities. This will sound very familiar to everybody now because it's literally adopting what is in 50,001, what is in all of the standards now in terms of the register of opportunities, and using that register of opportunities to prioritise your areas of concentration. And then phase 3 is implementation. So having generated your register of opportunities, prioritise it, identify where you're going to get the biggest bang for your buck, both in terms of the capital investment you have to make, the payback you will get, and then the ongoing operational savings that you will get out of it. And then you come up with your implementation phase. Implement it tightly, and make sure that everything that you design in the first place is delivered, because you have the baseline, you have the targets that you're going to implement against, and you monitor against it, and you make sure that the savings are delivered. And then the final piece, which for me, the design for energy management is an absolute key element of this. I'm an operations person at the end of the day. I'm responsible day in, day out, week on, week out, and 365 days of the year for the amount of energy we put into our product, the amount of resources that we consume. And this for me is absolutely key, that you make sure that in your design you build in everything you need to monitor your process 100% accurately, so that every time something moves from where it is expected to be, every time you have a deviation from the optimum, you can identify it. In fact, you don't have to identify it. It should signal to you if you have any sort of processes at all. And in terms of our aspirations, we were looking to reduce the cost of goods, we were looking to reduce energy, we were looking to get the consumptions down and become the most energy efficient brewhouse in the world. And we believe we've done that. And as I say, to showcase the new technologies. So, what did we actually deliver? In terms of the delivery, and very quickly I'll run through these. If anybody wants to talk to me about this afterwards, I'm more than happy to do that. In the limited time we have, I'll have to run through some of this. In terms of steam, we've reduced our steam input by 21.4 megajoules per hectolitre, from 85 down to 63. That's a huge reduction for us in terms of that. And we're targeting to do better than that now. With the monitoring systems we have in place now, we've already identified a couple of other opportunities which weren't clear at the start of the project, but we're now starting to do them. In terms of the electric consumption of the overall plant, we've reduced it from 32.3 megajoules to 27. Not as significant a reduction, but still very significant in terms of overall financial savings, because there's €1 million there for us. And then in terms of water also, we've reduced our water consumption down from just over 4 to just over 3 hectolitres per hectolitre. Again, huge savings, and very important in the environment that we operate in. And again, €1 million there. So overall, we're looking at, you know, €3.5–4 million that we've saved through this. And the thing for me, which is important, if you look, there's four bands there in those graphs. There's our original baseline, and then every time we did an exercise, we actually reduced it more. It wasn't a case of the aspirational piece came out at the start, we did a baselining exercise, and then we got to concept, and then we got to implementation, and all the time you dip down, and the implementation actually fails to deliver and disappoints. It actually delivered in spades. It's been very, very good. In terms of what were the things that we've done, in our brewhouse, particularly Equitherm, which I'll talk about later, it's a very innovative technology. Brewhouses haven't changed in 50 years. If you bought a brewhouse 50 years ago, you would buy exactly the same as you would now, except for some of the add-ons that we've put onto our brewhouse now, Equitherm being one of the key ones. Optimizing our vapor condensing. The comprehensive meter plan, as I said, that's paying big money for us now. And then, simple thing, brewhouses have always been supplied with double acting valves, air to open, air to close. We eliminated all of that. We've now got 90% of our valves are single acting valves, spring close, and that saves an absolute fortune in compressed air. And just a simple thing, and the payback on it is enormous. And that was just challenging an assumption of the supplier. No, we always supply them. German supplier, we always supply them like this. No, you don't. What did that deliver for us? 8,500 tonnes of CO2 emissions reduction, €2 million a year in the brewhouse alone. 36.2 gigawatt hours of electricity and steam reductions, and 500,000 cubic meters of water saving. The second element of the plant that was being upgraded was the coal block, where we ferment and polish the beer ready for dispatch in keg or tanker. Less delivery there because the process is less energy intensive, frankly, but still significant delivery in terms of you know, 500,000 pounds, nearly 2,000 tonnes of CO2, and over 100,000 cubic meters of water in the year. And then the last piece, which is probably closer to my heart because I actually run it, the utilities area. We've taken it down from 3.18 kilowatt hours per hectolitre to 2.5 kilowatt hours per hectolitre. Huge reduction. We have a hybrid refrigeration system. We have actually got two refrigeration systems, one running at 0 degrees, one running at -4. We knew we had to invest in condenser capacity. We've actually been innovative in the way we've done that, and we've been able to increase the COSP of the plant by somewhere between 16 and 20%, just by the innovative way that we actually implemented that process. Going for well water, we now abstract a lot of our water from a well which was in the plant for the last, I think it's about 104 years. I think 104 years ago it was drilled. We're now abstracting a lot of water and polishing that and using that for secondary functions around the site. And then our wastewater utilisation plant, we've hugely reduced our BOD loads and the costs that come through our Mogden formula through putting on much better screening processes, changing the way we're pumping in that area, and overall just having a far more stable process. We've also actually reduced the consumption of chemicals in that area by a factor of by 60%, just by the way we're running the plant. Total savings again about 2,500 tonnes of CO2 in the year, and another €500,000 in financial terms. So, what were these innovations? That's how a brewhouse works. Basically, a brewhouse is a big cooker. You take in your product, you take it from ambient water to 100 degrees to sterilise it and to extract the flavours from the hops and to prepare to convert the starches into sugars. That's what it is. You put a load of energy in. Traditionally, there have been ways of recovering that energy through an energy storage system, but there has always been a huge amount of waste energy. Brewhouses tend to be balanced if you boil off 4% of the contents of your kettle when you're boiling. We tend to boil off between 6 and 10%. Brewers differ on it, and brewers differ in terms of what they think is important and what drives quality. We believe we're in the right place at the moment, but it would have meant we would have a huge amount of excess energy, driven by the fact that we were using steam for both mashing and wort boiling. That's the way brewhouses have worked for 50 years. We now have changed it with our supply partners, and what we now do is we now only use steam for wort boiling, and the energy we can recover from wort boiling we then use both to heat up our cold water coming in and to do our mashing and to control the mashing temperature. So we have a huge energy recovery system in there, lots of stainless steel, big investment in terms of capital, but an investment that paid for itself in 13 months. So absolute no-brainer. It's a hard sell, mind you, but it was a no-brainer. In terms of what did that do, 10% reduction in the the total energy consumption of the brewhouse, so huge saving for us. It was an enabler in terms of maximising the LEED and BREEAM accreditation that we got. The brewhouse in Dublin, the building, has the highest possible rating in terms of both of those accreditation systems. CO2 emissions reduced by 800 tonnes just by this one initiative. And then, most importantly for me, 10 tonnes an hour reduction in peak steam demand. That meant that we could optimise how our CHP plant has operated. We can operate on one less unit running as and reduce the amount of supplementary firing that we have to do. And also then it mitigates the instances of surplus hot water. There's another big issue for us in the past is how do you shed all this heat? We're in the middle of the capital city. We can't just put vapour up the stack. We had to recover it and, believe it or not, throw it down the drain in the form of hot water. So it helped us in all those ways. Next thing, again, virtual metering, which again, I can't overstate this in terms of the ongoing management of your system. Metering is all important. Sure, I'm preaching to the converted here, but we've found in the last while, since this project has gone in, a number of opportunities that you can identify through proper metering, proper process modelling, and really understanding your process and understanding where the deviations from the norm, from the standard are. We did that with meters, but we also used secondary metering opportunities that we had, where we had a process that was monitoring flows and temperatures, and we could then calculate secondary loads. So what is the refrigeration load that's being extracted there? If we know A and B, we can calculate C. We've done that all over the place. And in terms of the brew house alone, it meant that we could produce 42 pieces of data, all of which are important, without actually installing the instrumentation to do it. It's all done through the software. It's all captured in the software. It's all modelled in the software. And that's 300k that we saved just through this project. And in the past, to be honest, what we would probably have done in the past is we would have installed maybe half or a third of those meters. So we probably only saved 100k on what we would have spent, but we're getting the benefit of the other 200k, and we are actually seriously getting the benefit of it. It's a bit of a whistle-stop tour. In terms of what we've done, I could talk about it for hours, but I didn't have the time. I've probably run through it a little bit quicker than I thought I was going to. But in terms of what's my summary, and I believe there will be an opportunity for questions later, but don't ask me any difficult ones. Hopefully you've got a flavour of the passion that Diageo has for this and the journey that we're on in relation to it. And we do see it as a journey. We do see it as something that we're going to have to continually develop, continually sustain as we go through our production cycles. Give you an appreciation of how St James's Gate Brewery and the centre of excellence we believe it is now is hopefully leading the thinking in our industry. It's not applicable in other industries, or it is in some cases, but we certainly believe that in our industry that we're leading the way. And in a sense of how important EED and that whole methodology was in leveraging the technology and that leading edge that we've got, and how it has paid for itself handsomely in delivering what we believe is a very, very good outcome for us. And then the practical examples, I know I ran through them. If anybody has recognised an opportunity there and they want to have a conversation with me, I'm more than happy to have that conversation, whether it be today or if anybody wants to contact me. I'm sure Ronan will provide contact details, and I'm more than happy to talk about. We're always happy to talk about this stuff. This is good stuff to talk about. All I'd say now is thank you for your time and your attention, and hand you back.
Thank you.
Thanks very much.